Alright, welcome back to the last of our videos on chapter 4 in regression. And so this last video I just want to kind of do kind of a freestyle kind of journey through regression using StatCrunch. And so I found this data set which is quite interesting, and so it had to do with responses to you and your mate survey. So it says the dataset contained responses to a survey ran on the StatCrunch site between October 2nd and October 22nd, 2009. Also, okay, so the respondents here provided their height in inches and their opinion of the ideal height of their mate in inches and their gender. Okay, so it says this dataset. It said in here that they removed 10 extreme observations. So probably what happened here is somebody was just goofing off and put some weird numbers in there. I don't know. But anyway, so let's look at this data here. Okay, so let's look at this here. Okay, so let me go here, and if I click on it here, get this here. Okay, so here's my data set. So here's just the gender of the respondent. So here they're only using binary, okay, meaning they're just using 0 1s to classify gender. Okay, and I always emphasize that because in some cases, you know, especially now and how it's always been, gender is not always binary. Okay, there's all these other categories for gender now. So some surveys now they don't have just 0 1 outcomes. Okay, so that's what I mean that it's binary, because a lot of other studies they're not binary. Okay, but anyways, so here this is obviously height of the respondent. I guess it's in inches, and this is height of the mate, height of their ideal mate. I guess, right? So if we just want to get a graph of what this looks like here, what graph do you think we're going to use here? Obviously, scatter plot, right? All right. So I guess what in this study, of course, this data is observational study. It's a survey data that we received, and I guess what would make sense here is that, when building the scatter plot, right? What am I going to pick as my X and Y? Well, because this is regression, right? We want to make this our explanatory variable or predictor variable. And so in terms of height and mate height, right? I mean, we want to use X to predict Y. So I think it would make sense here that we would use height of the respondent, right? And given that height, predict the height of their desired mate, I guess, right? All right, so obviously we're using height of our respondent. So it's pretty much like, given the height of a person, can we predict the height of their mate, right? Or their desired height of the mate. All right, so if we go ahead and look at this here, we get this data set here. So I mean, if you look at it, do you see a pattern here? I mean, it's kind of hard to tell, but I mean, maybe as height is increasing, right? As the height of the respondent increases, the height of the mate increases here. Maybe it looks like that. Kind of, I mean, that's what I love about StatCrunch. We're dealing with real data sets, and so sometimes it's just really hard to tell. Right? It's just really hard to tell. Right, but look here. Let me go ahead and calculate the correlation coefficient here. Let's see. Let me go to stat, and let me go to summary stats, and let me go to correlation. So here I'll keep for my correlation, I'll do height and mate height. Okay, this is what I get here. So my correlation here. Ooh, look at that. Correlation is very small, 0.02. Okay, so that's indicating a very weak linear association here, right? Very weak linear association. right? Very weak positive linear association, because this is very close to zero here, right? So it's like, that looks, I don't know what we can do here. I don't know if linear regression would be appropriate here, right? So we can even see what the regression output would give to us, right? So let's go to regression. Let's do simple linear. So I'm not really planning on anything here. I just want to see what it gives me, but I'm not really banking on too much here given what I've seen so far. So let me see, X variable, definitely it's height of the respondent. I'm using that to help predict the height of their mate. Okay, so we can compute it here. Oops. So even if you look here, right, right, look at this value here. Height of mate, 0.02, right? Very close to zero here, very close to zero. Right, and so this is the slope intercept, so same dependent is mate, independent is height, so that's correct. Our correlation coefficient was 0.02, and the estimate of our slope was 0.02. Okay, so the estimate of our slope, remember, is very close to zero, so at this case we become very skeptical. Okay, very skeptical. Right, and these are actually indicating that your model is useless. Okay, all right, we won't get too much into it, but see this p-value, see it's not, we don't have that less than sign in there, right? So it's kind of indicating that that your model is useless. Like it's like, get out of here, you don't need regression. Now, even if you look at this, ooh, look at that line, right? Very horizontal, right? Very horizontal line here. All right, so I guess it wasn't cut out for regression. Right? I guess it wasn't cut out for regression. But one thing that may be of interest to us, right, is gender. I don't know, maybe we should look at this by gender, right? Because a lot of times we uncovered a lot of useful patterns by kind of breaking things up by groups, right? So let's revisit scatterplot, right? I mean, because they give us this third row here, right? This third column, sorry, gender, right? Of course, this is a categorical variable, it's just coded as zeros and ones. 0 represents female and 1 represents male. Okay, so think about, what female's ideal height of mate is and what male's ideal height for their mate is. Do you think they would be the same or similar? Do you think both male and female correspondents will want a mate that's taller? Do you think both of them will want to make that shorter? Or do you think they might be vice versa? Right? Do you think maybe females want someone who's taller? Right? And maybe males want someone who's shorter. Right? So let's just look at this graph. Let's revisit the scatter plot again. Okay? And let's do the same thing. We still want to use height of correspondent. That's our explanatory variable, which is the X variable. And we'll want to use that to help us predict the height of their mate. Okay, but now what I'm going to do is group. Okay, I'm going to group by gender. Okay, group by gender. And let's see what we get here. Whoa, look at that. Wow. What a big difference, huh? Look at, you have two clear patterns here, right? So here, these blue dots correspond to the respondents of the female correspondents, and you kind of see that their heights, right, are kind of shifted to the left here, right? And here in the red, these are the gender male, okay? And you see that all their heights are kind of more or less shifted to the right, because I guess, on average, males are taller than females, and we kind of see that here. And you kind of see this line, right? They're really cut straight in the middle of the line. See this 50 and 50? They're kind of evenly spaced apart, right? What I'm going to do is because really this is if you remember algebra, right? This is like my first quadrant, right? So I'm going to split it right in half. Okay, split it right in half. Let's see, polynomial 1, I want to do best fit. So I'm gonna, actually no, I want to do the line y is equal to x. Oops, sorry. So this is saying, hey, pick the line, tell me what the y-intercept, tell me what the slope is. So I'm saying y-intercept is 0, slope is 1, right? So what I'm doing is I'm drawing the line y is equal to x, right? And see if you can remember from your algebra why I'm doing this. Okay, but ooh, there we go. Okay, the same graph here. So what did I do here? Is remember, this is the first quadrant. So here, this line indicates where y is equal to x, right? So everything above this line, y is bigger than x. Everything below this line, y is smaller than x, right? So if I put it in context, everything above this line, right, the mate height is going to be larger than the height of the participant, right? So for women, right, I mean for females, okay, we get that their height in comparison to their mate height is they envision the height of the mate being taller than them, okay, being taller than them. And if we look at the males here, right, they're all below this line. So below this line, the values of y are smaller than x. So what does that mean? Right, it means for most of the males here, right, a large percentage, right, is that their ideal mate height is shorter than they are. Okay, they are taller than their mate. Right, you see that there? Okay, doesn't happen for all. We kind of get these cases out here. This is definitely like an outlier out here. If you look here, the height of the respondent is 48 inches. Right, so they're saying that this male is 4 feet tall, right, and that their mate height is 72 inches. Okay, so that's 6 feet tall. Okay, so they're envisioning their mate being 2 feet taller than they are. Okay, so this is kind of a funny observation here. I don't know what it is, but it's there. Okay, but anyways, so we see these here, right? So now, if I were just to focus on the blue, I see a much stronger positive linear association. And if I focus on just on the red, I see a much stronger positive linear association, right? But I should keep an eye on this point out here. I should keep an eye on that point there, right? Because that's definitely an outlier for the red. Okay, but do you see how by using StatCrunch and just kind of using by groups, we just at first we saw no pattern at all. And now we see 2 clear-cut patterns, and really, it shouldn't surprise us that much, right? That the males would prefer their mate to be around their height, a little shorter, right? And females would prefer someone around their height, but a little taller. Okay. And this line here is not a regression line; it's just the line y is equal to x. So I broke it up. So all the points here, y is bigger than x, mate height is bigger than height of the correspondent, and all the points here, height of correspondent is larger than the mate height. So this is where your algebra comes in handy. Okay, but remember, everything that we're doing here is in context. Okay, is in context. So now let's go and look at the regression now. Okay, let's go here, stat. Let's look at the correlation. Sorry, let's look at the correlations now. Okay, so let's look at the correlation between mate and height, and let's group by gender, right? So within each gender, calculate the correlation. And what do we get here? Whoa, you see a big increase now. Okay, so when gender is equal to 0, that means we have female. The correlation is 0.61, right? And if we're looking at the correlation between mate height, where it's male, we have correlation of 0.44. Okay, 0.44. Right, so a big increase from the 0.02 that we saw before. That was the increase. So pretty much what I'm doing here is I'm getting ready to build 2 separate regression lines. And actually what we're doing is something called ANCOVA. This is called analysis of covariance. Okay, we don't have to call it that. It's just we were just looking for the pattern and we found it. All right, we decided to use this extra categorical variable to our advantage. All right, so let's build the regression lines for each. Right, so here I could go to stat, and I can go to regression, and we'll do simple linear again. And of course here I'm going to use respondent height. We're going to use that to predict the height of the mate. And check this out. I can group by gender. Okay. Okay, so we can go ahead and do that there. And here we go. Okay, so let me just pull this here. Okay, so if you look here, this is for genders equal to 0. So this is for the females. Okay, so what it's telling us is that if the predicted mate height is equal to 27 inches plus 0.67 times the height of the correspondent. Okay. Okay, so what this is saying is that our sample size is 114. A correlation coefficient is 0.611, indicating a somewhat strong positive linear association. And this 0.37 indicates that 37% of the variation in height of mate is explained by the height of the respondent. Okay. Okay. So, and if we want to find the predicted height of mate, this is the equation that we use here, right? And kind of these p-values, I mean, we're not really talking about these, but this is indicating that we have a good model now. And if we were to fit this just over that data, this is what it would look like. Okay, so what we have here, this is just a scatter plot, right, of the distribution of the women, of the female, okay, outcome. So this is all the female heights and their preferred mate height. Okay, of course we could take a look at what's here, right? This is definitely perhaps a maybe that's perhaps an outlier or influential value, right? That's kind of funny out there. We should see if this outlier is indeed influential. Okay. Okay, and if I go here, well, we'll come back to that. Okay, and if I go here, gender is equal to 1. This is for the male. Okay, so what we have here is that the predicted mate height is equal to 38.69 plus 0.39 times the height of the respondent. Okay, so we have 140 males in the study. The correlation coefficient is 0.44. So I mean that's, you know, kind of strong. I mean it's a positive linear association, not very strong. Okay, and then the R square is roughly, you know, 19.7%. So let's say 90.7% of the mate height is explained by the height of the respondent here. Okay, and but we get a much smaller correlation here, right? And this value here is, this is saying, you know, for every 1 inch increase in the height of the respondent, the expected height of the mate will increase by 0.39 inches, right, for interpreting the slope there. Okay, so if I look here, we have this again, right? We have this line here. But, you know, for this, you know, this point's really bothering me. Okay, it's an outlier, right? It's an outlier, and it definitely could be an influential point. Okay, so let me remove it. Okay, let me remove it. So let me go to row 1. I'm going to remove this point and refit the line and see if there's any difference. Okay, so just remember here. Okay, just keep note of it. Okay, we get 38 and 0.39. Okay, 38 and 0.39, and we have all our summary stats here. Okay, right, we get R is 0.44, right, and things like that. Okay, so let's go here. Okay, let me close this out. Let me move this over here. Okay, let me find this observation here. Oh, here it is. Okay, what I'm gonna do, you know what? It's gonna delete me. Okay, oh, this is the same one, right? So the height of the respondent is 48 inches, so they're 4 foot tall, and their ideal height of mate is 72 inches, so it's roughly 6 feet apart. Yeah, so let me go ahead and delete it. Let me just delete it. Delete it. Delete it. Okay, now I'm gonna do the same thing. Okay, so remember what these were, and let's see if they change. Let's see if there's a big change now. Okay. Okay, so here's what the line looks like. Here's R is 0.44, and then we get 38 and 0.39. Okay, so what I'm gonna do now is I'm gonna do this again. I'm gonna see if these numbers change. So let's see here. So I'm gonna go stat, regression, simple linear. This is still gonna be Actually, what the heck? Yeah, so we'll just go, this is gonna be height. It's gonna be mate height. We're gonna group by gender, and let's compute. Okay, so I'm gonna kind of show these side by side. These are like my old results. Okay, these are my new results. So obviously, I mean, for gender is equal to 0 female, nothing's gonna change there. Okay, because we didn't remove anything. Okay, but let's go here. Okay, so now let's compare now. So gender is equal to 1, gender is equal to 1. So let's look at the correlation coefficient. It went from when we with the point, it was 0.44. Without the point, it went to 0.577. So, I mean, in terms of correlation, a big increase, right? Here, my y-intercept was 38.69. Here, it was 26.16. A big difference in the y-intercept estimate here. And then for the slope, I go from 0.56 to 0.39. So a much bigger increase in these estimates. So we get completely different numbers just by removing 1 point. So at this point, this outlier, we now call it an influential point. All right? Not all outliers are influential. Okay, when we remove it, they're not going to have this big of a change. Okay, so let's look at the lines now. Okay, so I get this versus this. Okay, so it's kind of hard to see because now we're zoomed in a little bit more. But you see these two dots here, right? So this line was pulled up because of this point here. Because of this point, the line was pulled up. That's what it means that it's influential, is that it pulls your line in the direction. Okay, this single point, because it's an outlier, carries heavy weight, and so it pulled this line towards it. Now, once we remove the line, the point, which remember it was right here, it's gone now. Right, the line dropped down. So see, it's above these 2 points. Now it's below these 2 points. Right, so it's not as influenced by a single point. And if you look at this line, it seems to be a much better fit than what we had before. Okay, so from here, I would use this data here to model the association between height and mate height for the males. I would actually remove that point because it's very consistent. Doesn't make any sense, and it has such an influence here. You know, if we're dealing with histograms, okay, well then we just use a median. Okay, we go from using average to median. Okay, but for regression, as far as the models, regression is just like one big mean. Okay, this red line is one big mean. and right now we can't think of it as a median, right? We don't. I mean, for stats, M15, we don't have a median regression line. Okay, we just, I mean, I have one, but for M15 we won't talk about that topic. Okay, that's more advanced statistics. Okay, so this red line is just a mean. Okay, there's no way around it. So if we have outliers that are like this, that have such a high influence, we have to remove it. Okay, we have to remove it. Okay. So you see here we get a much improved fit and a better fit. Okay, but in this example, we just wanted to show you, kind of the thought process that goes behind creating and telling the story behind the data, right? Because when we first saw the data, there wasn't that much of a pattern at all, right? Not until, right? Remember our very first graph that we constructed. Right, look like this. Right, and from this we're like, there's no pattern observed, right? There's nothing here. Right, but we use that extra information, we use that extra variable. Okay, sorry, I don't know what happened there. I just lost everything. But anyways, I mean, the lesson was done. I mean, we just used this extra variable here, right? So we just did the simple scatter plot between those and we didn't find anything. But we used this piece of information to create two separate regression lines. I mean, pretty much what we decided is that, well, we need the phenomenon for females and males, they differ, right? We're saying, well, males prefer similar height but shorter, females prefer similar height but taller. And so it doesn't make sense to put these two data sets together. And so we had to separate them by using this by option here for gender, right? Once we did that, it became a lot clearer that there were these two positive linear associations, right? And all while we're working on these things, we're checking for things like this, right? Kind of weird outliers that could potentially be highly influential. Okay, so really quickly, we could just do simple linear. Okay, height, mate height, mate height, and then group by gender here again. All right, we get this value here again. Alright, so here obviously we found, that's influential, we should remove it, and that's what we did. And then, of course we could check this value too, right? There may be another one here. If I highlight over it, it's saying here, remember this is for females. We have a female who's 48 inches tall, so roughly 4 feet, and their ideal mate height is 1 inch shorter than them. Alright, so we can even dig into this a little deeper and say, well, this is definitely an outlier. Is it influential? Right, so I can go into this data set here, find this point, alright, and I can say, you know what? See ya. I could just remove it. And what I'll do is I'll just go back to here and I'll fit it again. So here I'll do height, here I'll do mate height, and here I'll do group by gender again, and let's compute. Okay, now let me just pull this here so we can compare it. Okay, so once again, if you look at the estimates here, right, the intercept was 41, so this is gender equals 0, gender equals 0, this is female, so this is the one where I removed that point. So here we get the estimate is 41 for the y-intercept. Here it's 27. Right? Kind of a big difference there. Right? And if we look at the slope interpretation, here we get 0.45, whereas here we get 0.67. Right? So maybe a big difference here. Right? And then the correlation coefficient here proved to be much stronger. Then here it kind of decreased and is much shorter. Okay, so if we look at these lines here, we get something like this versus something like this. Okay, so what we note here is that without this point was kind of pulling this line down, hence it pulled down the y-intercept and made it a lot smaller. Right, but without this point being up here, right, this line kind of shifted up a little bit, and when it shifted up, right, it shifted up and it leveled out a little bit. You can't tell because this is zoomed in, okay, but we see kind of a different association there. Okay, but we do get different numbers again, right? So we kind of get this outlier again, this influential point, right? So each of these have one influential point, which we can remove if needed, but you see there's a big difference here, right? So we have to remove it. But this is just kind of like a real in-depth analysis, and the reason I show you this is just to kind of show you the nifty things that we can do with StatCrunch and how we can uncover a lot of patterns very easily using technology. Right, so this is why we have a big push for moving away from like a graphing calculator, right, and into using some powerful software, right? StatCrunch allows us to do all that without that much programming experience. Okay, but other than that, I just want to show you that simple StatCrunch example. Hope you enjoyed it. We'll see you later. Bye.